Go ahead and open up to page 48 in your workbook and take a few minutes to complete practice problem number 1 at this time. Go ahead and circle below which of these statements is true about the data in the scatter plot. So please press pause, answer this question, and then check your work with mine as soon as you're ready. Excuse me. So the question asks which of these statements is true about the data in the scatter plot, and hopefully you answered choice B, which states as X increases, Y tends to decrease. So this is showing a negative association. So as you can see, our X values are going up while our Y values are decreasing. So that would be the best choice to describe this data set here. So please make sure you have that selected. And when you're ready to move on, we shall do so. All right, so we are still working on our second learning target, which is being able to understand how to analyze the associations between two variables. At this time, we should be already successful with the first one, understanding how to represent and analyze data in a scatter plot. And then we will next week get into understanding how to use segmented bar graphs and two-way tables to further analyze data. Today, you should be able to walk out the door knowing how to use a scatter plot to decide if two variables have a linear association. You should also be able to know or to pick out clusters in data from a scatter plot after today's lesson. For as far as our mathematical practices go, we will be continuing to model with mathematics on our scatter plots and looking for and making use of structure within our scatter plots and taking a look at their associations, positive, negative, or possibly no association. We will explore that further as well. Okay, at this point in time, I need you to turn to page 50 in your workbooks, and I'd like you to take a minute after we read through this together to complete the notice and wonder on page 50. A little bit of background about this data. It represents oil production and prices are shown here. Oil production is measured in 1,000 tons, so a point on the left side of this data graph, or excuse me, of this graph represents 250,000 tons. Price is measured in dollars per barrel. A barrel of oil is equivalent to 42 gallons. The prices in this chart are for crude oil, which would still need to be processed to be made useful for gasoline, plastics, or other oil-based materials. Excuse the bells, sorry. All right, so at this point in time when you have a little background information, go ahead and pause the video and just jot down at least one thing you notice and one thing you wonder about this data, about this graph, either somewhere next to it or right underneath it on the top of page 50 there. And when you are done, you can check your notice and wonders with me. All right, so a few things that I noticed about the data was that the points don't all lie near a line like they have in previous scatter plots. A second thing I noticed about the data was as the production increases, the price tends to decrease. So at this point in time, if you did not notice either of these things, if you could please add them to your notes. And go ahead and pause the video so that way you can go and do that at this time. If you notice something additional other than I have noticed, that's great. But these two really are some of the main takeaways for what's going on here in the graph as far as the notices. Let's take a look at some of your wonders or possible wonders. Some wonders that I had were, what does oil production or import prices mean? If these axis labels are unfamiliar to you. Is it okay to model this relationship using a line? And why does it seem to level out at the end? So I'm going to scroll back up to see that. So if you notice right here, we're referring to that area leveling out. If you have a different wonder, that's totally fine. But if one of these tend to stand out to you and you wondered the same thing or thought about the same thing, go ahead and jot it down in your notes at this time now. And hopefully by the end of today's lesson, we will address several of these wonders. So feel free to pause and add to your notes as needed on page 50. When ready to move on, let's do so. All right, the next activity, oh, I'm sorry, this is still in addition to the notice and wonder, just a little bit more information provided to you. It says, even when a linear association seems to be present, it may only fit the data very close to the data that is present. For example, if we cover up the scatter plot to the right of 300,000, so that's right here, right? So if I were to cover all of this data that I'm circling around is what we're referring to. There may appear to be a linear association that would fit the data, but it would not apply to the data on the right-hand side of the scatter plot. So meaning when we're looking collectively, we can see that this data is starting to curve, right? So a linear association may not be the way to go here, but we're not saying that there's no association whatsoever, right? So additionally, in this particular situation, a linear model does not make sense in the long term, since the linear model would eventually have a value of 0 and then become negative, something that would probably not happen to the price of oil. So things to consider in real life as well. All right. Moving on to the second activity. This activity today you're going to actually complete on Google Classroom. There is a Desmos link connected to our classroom where you will complete the sort. So I know there are some questions at the bottom of page 50 and the top of page 51 in your workbook. These questions are embedded on the digital version, which again is linked to our Google Classroom page. So at this time, I'm going to ask that you pause this video and you log on to Google Classroom and complete the Desmos sort on your own by clicking on that link from our classroom page. And these questions, like I said, will be answered there. You can feel free to answer them if you want them handwritten in your workbooks as well, but you will need to type them in on the actual sort on the Chromebook. So go ahead and pause the video and do that now. All right, so these were some of the graphs from your sort. Okay, so just some follow-up questions to think about from the sort that you just completed. How did you originally group the cards? So was there a certain method to which you grouped them? Did you group them on positive association, negative association, linear association, nonlinear, those kind of things we are looking for. Which graphs did you sort into the positive group? Looking back, hopefully you sorted graphs F, G, and possibly H into the positive group. So you can see as it starts to go down, well, H actually, I would think definitely G, positive association, definitely F. H can actually go down and then come back up. So that might be better sorted for both or neither. Are there any cards that did not fit well with either positive or negative association? So just like we were just talking about, A would be one of those, right? Because it has a positive association, but then it comes back down and has a negative association. So that probably didn't fall into either category for you. And again, we're seeing a similar like trend, but the opposite with H, where the data is decreasing and then increasing, or having a negative association and then a positive association. Which graphs did you sort into the linear association group? So not all of these appear to be linear, right? So I could probably make a claim for graph B. I can draw in a line that, a prediction line that seems to fit a majority of the data. So B, we can make an argument for linear data. I would also say C we can make a strong argument for negative linear association. D has that curve, so I would not put D in the negative, or excuse me, in the linear association. E, we can definitely make an argument that we can show a linear-like path here, again, negative. F, I would not. I'm seeing a curve occur here, so I would not put that in linear data. I would, however, keep it as positive association, but it's just not linear. And then G, again, I would make that nonlinear because, again, we're seeing another curve happen. I would also put it as positive association, but definitely not linear. And H, not linear because we're seeing that curve happening in two directions. That first, that negative association, and then curving, trending upward to show a later positive association occurring. If a scatter plot has no association at all, neither linear nor nonlinear, what might its scatter plot look like? So something to think about. All of these had some sort of association, whether it was linear, nonlinear, positive, negative, or a combination of both. So if a scatter plot has no association at all, we discussed this the other day, that really there's no relationship between the X data and the Y data. So it may look something like this, where the data is simply just kind of scattered all throughout, and you just have all these sorts of random points plotted all over the plane here, which would indicate that there's no association whatsoever. So just some key wrap-ups hopefully you discovered or thought about from the sort you just completed on Desmos on Google. All right, so now that you're done with that sort, let's go ahead and turn to page 51, and we're going to look at activity 7.3, clustering. At this time, I'd like you to, again, pause the video and jot your ideas down on these 4 graphs and tell me, how are any of these scatter plots alike, and how are they different? And as soon as you're done jotting down your own thoughts, you can go ahead and press play and resume the video to check your responses with mine and add to your notes if needed. So some responses, or some things that I noticed on how they're alike and how they're different, are right here as follows. So what I stated is, first, plots A and D, so graphs A and D, both have negative associations, but D has a gap in the data. So A and D are the two that I'm comparing here, right? So see, you can see that negative association, again, negative association, but here's that gap. So that makes a difference. So they're alike in the sense that they both have negative association, but different because D has a gap, or that whole like missing data points, it almost looks like. Another thing that I noticed was that, when comparing and contrasting, plots B and C both have 2 groups of data that would have different lines of fit. In B, both lines of fit would have about the same slope, but in C, one slope is positive and the other is negative. So, excuse me, let's go back to both B and C. So I'm going to scroll back up. So if you take a look, there almost looks like there can be 2 prediction lines drawn in, right? So here's one. Here I can draw in possibly another. Okay, but same thing in C. I can draw in one prediction line here. I could possibly draw another prediction line in here. But the difference is B's, both of their prediction lines appear to have positive association, positive linear association. And C, one of the prediction lines would have positive linear association, but then the second one would appear to have that negative linear association. So that is quite a difference from B when comparing those two. I then compared plots A, C, and D, and I noticed that each have data in quadrants 1 and 4, but plot B only has data in quadrant 1. So here is B, right, over here. All of my data in B is in quadrant 1. But if I look at A, here's my x-axis. It goes into quadrant 1 and then trickles down into quadrant 4. Same thing with C. Here's my x-axis. Sorry about that. And I'm seeing data in quadrant 1 and again in quadrant 4. And then D, again, here's my x-axis, and I'm seeing cluster of data here in quadrant 1 and 4 again. So at this time, if anything that I may have in my notes down here are different from what you have, please go ahead and add to your notes at this time at the bottom of page 51. So feel free, pause the video to do that, see what you wrote, compare it with mine. And if you may have missed something, now's your chance to jot it down. And when you're ready, we'll resume to the next part of the activity. All right, so when data seems to have more than one pattern, we call this clustering. Clustering of the data, like in graph B, C, and D, can reveal hidden patterns. Usually, clustering means there are subgroups within our data that may represent different trends. So if I backtrack, here in B is a cluster of data. Here in B is a second cluster of data. Okay, again, that happens in C. Here's a cluster of data, second cluster of data, right? And then again, we can see that in graph D, cluster of data, another cluster of data, versus graph A, which has one general cluster of data, right? Okay. Let's go ahead and turn to page 52 in your workbooks where the lesson summary is. These questions here that are on the screen are not in your workbook, but I would like you to add them at the bottom of page 52 where you have some open space there. The first question I'd like you to add and think about is, in your own words, what is a nonlinear association? Then I'd like you to jot down, what does a nonlinear association mean? In your own words, what are clusters in data? And what do clusters usually mean? So once you get these questions jotted down, go ahead, pause the video, get them in there, and think about these questions and jot your responses down. And once you're done with that, you can resume the video and check your responses with mine if you need to add anything. All right, so for question 1, in your own words, what is a nonlinear association? So I was looking for you to hopefully write something along the lines of, the points in a scatter plot do not lie along a straight line. So if you do need to add to your notes in regards to this question, please do so. If you wrote something along these lines, then you're perfect. Question number 2, what does a nonlinear association mean? I was hoping that you were thinking something along the lines of this. There is not a constant increase or decrease of one variable based on the other. So what does a nonlinear association mean? There is not a constant. That is the key word here, is constant. Because we know when data is linear or has a linear association, there is a typical constant rate of change that we can identify based on our fitted line, like we saw in yesterday's lesson. So if you need to add to your notes for this question, please do so. And press pause. For the third question, in your own words, what are clusters in data? So for this question, I was looking for an answer along these lines. The points in a scatter plot are clumped together in different groups. So that's what clusters in the data are referring to. If you wrote something close to that, you're fine. If you need to readjust your response, please do so. And then finally, for the last question, what do clusters usually mean? They mean that there may be multiple patterns present within the data. Perhaps there are subgroups that show different patterns. So again, if you need to add to your notes at this time in these responses, please do so. And when you are done, we can go on and take a look at the lesson summary. All right, so moving to the top of page 52, here's our lesson summary here. Sometimes a scatter plot shows an association that is nonlinear, right? So if we look at this data is clearly curving. We call such an association a nonlinear association. In later grades, you will study functions that can be models for nonlinear associations. Sometimes in a scatter plot, we can see separate groups of points. We call these clusters, just to sum up that. Okay, so then identified in your book there. All right, at this time, I would like you to go ahead and end the video and work on your Lesson 7 quick progress check on the yellow sheet that you grabbed from the tray as you entered the classroom. When you are creating your own scatter plots, they can be very general. Just make sure to label your X and Y axes. If you're just going to label them X and Y, that's fine. They don't have to be super detailed, just enough to give me the information of what each of these questions is asking for. So you're just doing a rough sketch of something that would show me positive linear association and clustering involved, and then again a rough sketch of a scatter plot for number 2 that shows negative nonlinear association, and there does not need to be any clustering involved. So take a few minutes and complete this and turn it into the inbox when you're done. And if you finish this prior to the bell, please work on the practice problems in your workbook on page 53 and 54.